So far, we've looked at some linear functions, we've looked at quadratic functions, we took a look at power functions. Polynomial function is really just made up of a whole bunch of power functions added together. So basically, a bunch of different terms that each have an x to some exponent in them, and then we throw them together. So quadratic are actually polynomial functions. There's a certain number of x squareds, a certain number of x's, and a certain constant. So we'll start off, I'm not going to get into the definitions too much because we're going to get into a really ugly one in a second. Let's just give an example of a linear function. So a linear function would be something like f at x equals 3x plus 5. So we have basically this part here, which would be considered a power function by itself. 3x is a power function, and 5 is a constant function, but that would also be considered a power function as well. Quadratic, very similar, except this time we're going to have some x squared term. 7x squared minus 2x plus 6 would be a perfectly valid quadratic. Cubic, we can keep going here. And the numbers I choose are completely irrelevant. They don't matter. I'm going to put some negatives and decimals in here just for fun. Negative 1.5 x cubed plus 7.3x squared minus 2.1x minus 8.9. Okay, so as long as the coefficients of the x's are real numbers, positives, negatives, decimals, fractions, doesn't matter, and the exponents are all whole numbers, 0, 1, 2, 3, 4, 5, etc., we're fine. And then by the time we get up to quartic, which is why we're not going to deal with these too much, we start to get into some, pretty long, ugly stuff. So we have an x to the fourth term in it, minus 3x cubed plus 5x squared minus 4x plus 6, for instance. Okay, so we're starting to get into the point where it's tedious to write these out. Unfortunately, in mathematics, we like to be able to write out things in general form. So the general form for a quadratic is that giant, long, nasty string there. And if you look at it closely, even though the notation is horrible, it's really saying something fairly obvious. It's just saying that there's some coefficient. In this case, it's saying coefficients are a sub 0 at the end, and that's the way we read it. It's a with a subscript of 0. And then in front of the x, we have an a sub 1. In front of the x squared, we have an a sub 2, and so on up to a sub n. Those are just saying that they're some coefficient a, but we don't want to call them all a because then it looks like they're all supposed to be exactly the same. So we just give them subscripts to say they're different. So these are all just a fancy way of saying you've got a bunch of terms that are all some number, some real number, times x to a whole number. That's it. So you'll never have to write that out. You'll never have to mimic that, but that is what it looks like in general terms. Some terminology that we have to get is, we'll apply it in some situations here. The number in front of all the x's, those are called the coefficients. So you'll notice I've already used some of these terms before. I'm officially introducing them now. But coefficients are just those numbers, the a's, that go in front of each of our terms. The number in front of the x with the largest exponent is called the leading coefficient. And it's important because it tells us a little bit about our end behavior that we saw back in the power functions lesson. It tells us whether or not we're going to be starting low, ending high, or vice versa, or whatever it is. So the leading coefficient gives us a fair bit of information. And I want to be clear, the leading coefficient's not the first coefficient you see on the left. It's the coefficient in front of the biggest exponent term. So you may have to look for the biggest exponent term if they don't happen to be in order. I may try to trick you. It's not a trick if I tell you about it, I guess, ahead of time, but I may try and trick you by putting a term that's fairly high in the middle, in which case the leading coefficient may be actually in the middle of the polynomial. The largest exponent on x is called the degree of the function. So on linear functions, the largest exponent we see on x is 1, so it's degree 1. Quadratics are degree 2, cubics are degree 3, quartics are degree 4, and so on. And the number that has no x in it at all is called a constant term. And that's because it's always going to be the same value no matter what x is. So in this particular polynomial that we've given as an example, f at x equals 4x to the fifths minus 7x fourth plus 2x cubed minus 6x squared plus 10x plus 15. How many terms do we have in that polynomial? So a term is just anything separated by a plus or a minus. So we have 1, 2, 3, 4, 5, 6. 6 terms in that particular polynomial. The coefficient of the x squared term, I want to be careful we include the negative sign if there is one. So it is negative 6. The degree of the function is just the largest x that we see anywhere. And in this case, the largest x I see is right there. That's an x to the fifth. So we're going to say 5 is the degree of the function. It's actually a quintic. But again, we don't have to know the names for anything really above cubic or quartic. We just say degree 5, degree 6, degree 7. Leading coefficient, the largest exponent is 5, and its number in front is a 4. And the constant term, that's the one at the end. That's the one with no x in it, because it will always be 15 no matter what x is. Whereas, say, for instance, the term before it, the 10x, that term will be equal to 20 when x is 2, and 50 when x is 5, and 100 when x is 10. So it's not constant. All right, that's really all there is in this lesson, is that terminology. We're going to move on in the next lesson to do the actual modeling and start to get into being able to come up with functions for large polynomials so that we can basically look at a picture and figure out what its equation is relatively easily. But just before we do that, I do want you to practice some of these terminology ideas and just go through a couple of these practice problems here. The answers are at the bottom. Make sure you double check them to see that you're doing it correctly. And if you are, fantastic. And if you are not, be sure to contact me and let me know so I can help you through them. All right, we'll see you in the next lesson.